this time with Etan from Nimbus. So thank you so much for everyone for joining, but especially Etan. It's great to have you here. And yeah, so after a brief pause last week, we have a proper core developer mentor here today. Ethan working in what used to be status, and now I'm doing working on Nimbus on consensus layer. They also started execution layer client. They work on SSZ across both layers. They work on many cool proposals that I believe are making Ethereum more secure and resilient. And Ethan maybe championed some of these, but he's been also mentoring them for EPF for a couple of past years. So I think that he has also interesting insight into how how the fellows have been doing and what was like working with them. We had you actually last year for the in-person sort of panel in Cannes, but never online. So finally a proper like a whole AMA just dedicated to Ethan. So yeah, thanks again for being here. And maybe just to get started, to give people some context, please tell us about yourself, about maybe what you did before Ethereum, how did you get into the ecosystem, like something about yourself.
Sure, sure. Hi, everyone. Just double checking again. Audio is okay, right? Okay. So how did I get into Ethereum? I'm in Ethereum now for 5 years. I started right around the launch of the Beacon chain. Before that, I was working in embedded, like smart home. Like we made an SDK that you can put into small accessories like light bulbs or door locks, cameras, and these kind of things, so that you can connect them from the iPhone. Like there is a standard from Apple for that. And after that, because over the time it gets kind of repetitive, like you are just adding more profiles, but it's still the same tech. I was still interested in small devices, so I figured now that I have time, um, let me try to run my own node because staking is kind of expensive if you use one of the custodians. They charge like 10 or 15% of the rewards. So I set up a Raspberry Pi with Rocket Pool, and I was surprised how simple it is and how stable it was. Like you just log in like once in a month, install a software update, and it works on a Raspberry Pi. And I was running Nimbus and Geth, so I was like wondering how these softwares work. And Nimbus, I started contributing open source just on GitHub, was very welcoming, like a different background from before. Like Smart Home is mostly proprietary, like closed source, crazy compilers, crazy platforms, and so on. And now it's like with Nimbus, it's like an entire tech stack. Like we have the compiler, we have the standard libraries, async, await, HTTP sockets, everything is under our control. And it's the reason why it's so tiny, right? So same background, small devices, but now with distributed systems, like without trust, right? You cannot just trust the controller to tell you what's right. Yeah, that's how I got into it.
Like yeah, it's very cool to people see people exactly from like this ecosystem, from like thinking about actual like hands-on hardware, and the realities of optimizations, of limitations in the software, like coming to Ethereum. I think it produces a bunch of great stuff. So maybe just to continue like further, like what sorts of projects you have now in Nimbus, or what excites you, what sorts of new features or some maybe long-term efforts you had within the team.
So for me, like it's a bit different than many others. Like on the big roadmap, you have like scaling and like cheaper gas fees and faster blocks and so on. For me, the important things, like the priorities are like how can we make Ethereum accessible to developers and to users? And that's why you see me listing all of these projects that try to improve that. Like the one I'm focusing on personally this year is the decentralized checkpoint sync. Today, if you start a new node, the first thing you have to do is you point it to some weird URL to download like the initial beacon state from. And I don't like this central server that you put in there and then you just trust it and, oh, now it works, right? I don't think that this is appropriate to like have on a credible neutral network, right? So I will try to make this decentralized. So far, I have also been reached out to by 2 of the current DPF, or even 3, depending on who sticks around. And that's great, right? The other stuff that is listed is this PureETH bucket that we also started last year. Tamagna is also here. He was an EPF fellow last year, and he made a lot of progress there. So there, this year we are trying to integrate his learnings from last year and try to make it more real, right? The idea there is that we want the wallet, when it fetches data from Infura or from Alchemy or whatever backend, we want to give the wallet the ability to verify that everything that it gets is correct and also complete. So and also for historical data. So today is like you ask Infura, what are my historical transactions? And maybe they are like, hey, today we have a bug and we don't tell you like about 1/3 of them, right? I mean, all of this stuff happens. We also had the RSETH KelpDAO incident, which was a similar issue where they minted some tokens without them actually having been minted. They just, someone told them they were minted, right? And then they had like these tokens that they can just spend on Aave, right? Yeah, light clients and just verifying in a decentralized way. No trust, maximum decentralization. That's like what I try to maintain or improve here. It's like the scaling is great to have, but scaling is already kind of solved, right? Like we have blockchains that have scaling, but Ethereum is unique in decentralization. And I think with every step that we take, we should at least make sure that we don't give that up or even improve it, like if it's possible. Question. Yeah, I mean, for the stake, that's just a necessity from proof of stake, because with proof of stake, we have the problem that validators who were active in the past, they can leave, like they can exit their validators. And after that, they are no longer slashable. So if you start your node with a state from 5 years ago, and those validators have exited that old state, like they can just make up a separate history and you cannot really decide which one is trusted. That's like called the weak subjectivity period. It's in every proof of stake system. You have to start from a somewhat recent state. And about the other question from Sagar, how is it decentralized if we are using these RPC providers? It's like different phrasings of decentralized, right? Like either we say it has to be something like the old Portal effort where everything is decentralized on a P2P style network, like on a DHT. That one is quite tricky because it's difficult to spread out the data in a way that is still low latency to access. Then this RPC infrastructure, it can still be somewhat decentralized by having public RPCs, and you can just pick like between 20 of them, so you trust them for data availability. But the key is that you need to be able to verify that all the data is correct. Otherwise, you can only rely on those with high reputation who have something to lose. But if you have the ability to verify, then you can start asking any RPC because they can no longer lie to you. Yeah, and then we had a hands up from Blessing Web3 Creed, I think. So I guess
Yeah, yeah, Etan. I don't know if you can hear me. Can you hear me?
yes,
Okay, okay. So I when you were actually speaking, I think you mentioned about you're working on decentralized checkpoint sync. So I'm just curious, right? Because I've been making research on checkpoint sync in general, right? So I'm looking at uh, so are you going to handle the non-finalized checkpoint sync? I'm just kind of curious in that area, the non-finalized checkpoint sync.
the non-finalized checkpoints thing.
Yeah,
Is that just like the thing where like you download a checkpoint and you don't really check whether it's finalized and you start it, or what is it about?
yeah, yeah, exactly. Yeah, exactly. You're correct.
The standard today, like you download a checkpoint and you assume it's finalized. There is nothing real that enables you to check whether it's actually finalized because like finality information comes later. Like you download that first state and then you download blocks on top of the block read. Finalized is just a note that tells it, hey, do not reorg deeper than this one block. It's just that.
Okay, okay, and also, so concerning the decentralized checkpoint sync, right? So are you looking at the checkpoint sync safety in general, the safety concerning it?
Yeah, I mean, today, if you don't start with anything, like if you don't put the URL, you start from Genesis, and like you just have to trust that whatever blocks are given to you are the canonical ones. And with the decentralized checkpoint sync, we can at least start with a later state, but we still have this initial thing where you start with the light client from a somewhat old trusted block root. I mean, it doesn't have to be that old, but like maybe half a year or so, so that it's not controversial anymore. You start from there, you use the light client protocol to go to the present, and then you know the latest block header, you know the latest finalized, and you can download the checkpoint from there, somewhere around that recent region. But in the end, I mean, it's still not perfect because like the sync committee, those messages are not slashable. And also, even if we made them slashable, it's very tricky. How do you punish it? Because like the sync committee is like a very small part of the validator set. And if you can hack that one node that controls like a super high TVL bridge, and like you have like billions in damages, it doesn't really matter if you can like after the fact slash like a couple hundred or thousand ETH, right? So security is very tricky to do there. My goal there is to provide a reasonable default for the majority of users. And I mean, it's probably more decentralized in a way when we can get rid of the URL, because with the URL, you don't really have security either. You just trust that that central Panda observer gives you the correct data. Obviously, you can always just verify that you are synced to the same chain as like Beacon Chain or Etherscan and these kind of browsers.
Okay, okay. And also, I don't know if you can have like a drafts article, like so that I can actually just check it up, like just read about it. I don't know if that's
Yes,
possible.
well, like on like I'm still working on text there. I should have something, and
Okay.
I can share it on. I don't know what the best channel is, but you'll,
I,
you'll
I
find
think Discord. I think Discord.
many different. Yeah.
All right. Thank you.
The base idea will be to use light client sync to the present, and then use a state that's somewhat recent, split it up into chunks that are smaller than a few megabytes, and then just fetch it together with proofs that they are correct.
All right. Thank you so much. All right.
What is 8.3 or an EIP or a pull request or?
Oh. Yeah, it's basically this trusted logs indexing. Yeah, mostly with the state, I mostly mean like historical one, because with the recent one, it will be in the system smart contract. So yeah, maybe that clarifies things a bit.
Yeah, for the decentralized log index, I mean, there have been many different designs over the years. So it's still a bit open which one of them will be the winning one. Who is storing it will be an open question, I guess. There's also the old one, I think 7745. Like that was the older one with the filter maps. That one was a bit challenging to implement because they wanted to do everything in the EL. But I think if we just move like 1 megabyte of data into the CL there, into the beacon state, that's already like 100 megabyte. You put like an extra megabyte in there that has like checkpoints, it would also work. Yeah, it's an open question. I cannot answer that one yet, but it is still being discussed. Tamagna is also commenting in the chat. But yeah, where to make it available? Yeah. Yeah, it's different to do the same. Like the same idea. Like the idea is how can we get the ETH-GET logs response verifiable? And verifiable means I want to be sure that no extra logs are included, but I also want to be sure that no logs were omitted from the response. So it's complete and correct. Yeah, I mean, the RPC providers, they already have the data for ETH-GET logs, so maybe they can store it together with the proof that it's correct. But I don't have a good answer there. Yeah, I mean, it's like the purist is like the umbrella term for everything that tries to make Ethereum verifiable, like trust minimized and so on. It has many different aspects. So one of the chunks is like this, the logging, like just ETH-get logs. That's like one big area. Then another big area is how do we change the EL data structures so that they are proof friendly? Because today with RLP, we have like these linear hashes. So like if you want to prove that a transaction happened, you have to send the entire transaction with all the call data and everything in there. And also sometimes you have to send the entire receipt with all the logs and the logs plume and everything. It's a lot of data just so that you can prove that like that thing has the correct hash and it's part of the Merkle-Patricia trie, right? So if we can change that to 3 hashes, that enables us an efficient form where you can like say, I only want to know who sent the transaction, how much it is, the destination, and maybe the first 32 bytes of call data so that you know like the function that's being called, right? With a 3 hash, you can do that. And that's like this 7807 umbrella, like the sub part of Puri. So we have the logs, we have the SSC data structures, then we have the decentralized checkpoint sync. That's like a third one. That's like a CL effort. And then we also have just general on the library side, an API. How can we make generic proofs? Because today we have beacon APIs that are like for every single thing, like give me a balance of a validator, give me the current activation state of a validator. It's like a new API every time. Usually they don't have any proofs. And we would like to have a generic ETH-get proofs equivalent for the CL that works on all the data structures. And last year we had June from EPF working on that. Like it's like SSC query language, but like just doubling down on that, evolving that. That's like another part of it. But yeah, I think how to get into this purist stuff is like you pick one of these areas and you just try to reach out to the people involved there. It's quite like, it's different people who work on different aspects there. But like I would recommend the ETH R&D Discord. There is like an SSC channel. There is also the Light Clients channel. It's a bit of a mess. Or just ETH Magicians comment on the EIP directly. I don't know, like what's the best? Chaos. Client data backfill is quite important because without that, like you start your node and it starts with today's state and it will only have the data from today going forward. All the data that's back here is not on the node. That means that if someone else wants to sync from you and they start from like a block route that's in the past that you didn't know yet, when you started your node, they cannot get that data from you. So if you want to reliably enable someone to sync from, let's say, 3 months in the past, let's say we start there. we need all the data of those 3 months widely available. And that means we need to enable nodes that have started syncing later to backfill what's missing. That's not possible today with the current protocol. It only supports forward syncing and forward data collection and so on. But if you want to get historical states, that's like an extra protocol on top. The good thing is that it will not require consensus changes. Like it's something that's like a layer on top. It's like a newly P2P gossip topic or request response, I think, probably request response, where you can get like the historical data and not every client has to support it. So we can ship it quite fast.
So my question is that so the light client only backfills to the weak subjectivity points, right? Like about 30 months, not back to Genesis, right?
I mean, right now it doesn't backfill at all because it can't, right? But we will have in like a period how far we want to backfill. Then we need the backfill protocol as well, and then we also need to like a checkpoint into the clients so that they know this is like a trusted, non-controversial checkpoint that we can start the system. And from this point that's in the client, the data has to be available on the network. But yeah, weeks probably only like 2 weeks, and they are like it's a bit of a mess because we have long validator entry queues. Like if you want to set up a new validator, you have to wait like 1.5 months to activate it. And if we want to make that faster, it means the week's objectivity period goes lower because like validators can exit and enter more quickly. But yeah, it's always a bit of a different number there. Right now, I think it's about 2 weeks.
I see. Thanks.
No worries, no worries. Can Yeah, that's like, just for context, that's like this strawmap.org. This is like the EF's current take on the future of Ethereum. What excites me about it is like the post-quantum stuff, like quantum, like we need post-quantum algorithms, like the current ECDSA, BLS, and KZG. They will not be secure anymore about 5 years from now. There is still like a period where despite them not being secure, we can kind of cheat by just rotating the keys more quickly than they get hacked. Like we can just, every time we sign a transaction, change the key, and then the next transaction needs a different key and so on. But that's obviously not very future-proof. I mean, it works, right? Because like the quantum computer can only get back the private key from the public key, but an address is a hash of a public key, and the quantum computer cannot reverse the hash. So it's safe, right? But yeah, this post-quantum stuff is super nice. The challenge there is to get a good scheme that works really well. Like BLS is a really cool primitive that we have. It allows us to create something like the beacon chain where we have 1 million validators that all sign the same message. I mean, it's not 1 million, it's like 30,000 per slot, right? I guess. Yeah. 30,000, is that right? Times 30. Yeah, 30,000 per slot that sign the same message. And with BLS, we can aggregate it into like one tiny aggregated signature that's still the same size. With post-quantum signatures, they are either very large or they are very time expensive to compute. It's like a big mess, right? Aggregation is not solved yet. There are some approaches that are stateful. So like every time you sign a message, you have to write something to disk to track, hey, I signed this message. The next time I'm not allowed to use this anymore somewhat. These approaches are also kind of bad because on desktop systems like fsync, this system call, it doesn't work reliably. Like if the power is gone and like you restart it, maybe the data is still not synced. Or like if your little hardware wallet breaks down, how do you tell it like how far did you sign, right? Like it's like these big problems. If you go stateless, it's different kind of problems, right? Then what doesn't excite me about it is like this idea of like a heterogeneous network where like we have this $100,000 machine that we rely on for the proving. Like we have this one mega server that is priced in a region that only allows it to be possessed by wealthy individuals and organizations primarily focused in the West. And I would like to retain the geographic distribution that we have with Ethereum. Like, I would really like to see someone find out a way how we can distribute the proving. Maybe like the Raspberry Pis at home, they can like each prove like 10 megagas, and then we can aggregate those proofs. Maybe it goes a bit slower, but I think it's still worth it to explore these kind of approaches that keep the decentralization of Ethereum. Otherwise, it's just like another one of these high performance blockchains that has a couple mega servers in some data centers. Also, I dislike this mixing of concerns like post-quantum and zero knowledge and issuance. It's all fused together in this one roadmap without anyone really asking why does it have to be together. So those are like the things that worry me a little bit here. Like also, who is making these decisions? Like who is making the straw map? Is it the same entity that funds all the teams? Is it the same entity that operates like a lot of these validators and so on? So yeah, decentralized proving with aggregate. Yes, exactly. These kind of proposals, I like them a lot. I'm not like an expert in proving or zero knowledge, but if you remove the mega prover, keep it decentralized, find a way on accessing the data, like that's another thing. Like if we put the execution payload into blobs and you don't really know which blob contains the data for your own wallet, and you have to run a super node to get all the blobs and then filter through them, It's a problem. Like we lose something that we already have today, right? That's the risk that I see. But yeah, I mean, lots of questions still on that roadmap. Like the short-term stuff is relatively clean, like the fossil we already agreed on as client developers will be the next big thing that will help with censorship protection, because like the validators can force include certain transactions, like that the builder has to include or the block becomes invalid. But yeah, just we have to make sure that everything stays decentralized and like no compromises there.
Hey, can you hear me? Cool. Yeah, so I actually totally agree with what you said about like you cannot just simply let proving and executing be centralized. I mean, that is such an enormously terrible thing to do. Like letting a testing be more decentralized is more important, yes, but this idea that we can just have like arbitrarily centralized proposers and executors is like almost equally as terrible for like a number of different reasons. But like that's why I was talking about like an execution tree. As you said, you split the role into across multiple, actually weighted by stake, and then you aggregate. You don't just let like one like entity do it all. So that was my proposal there. I actually wrote about 2 days ago for lean execution is like doing exactly this. Parallelizing, aggregating recursively. And then, yeah, there was something else. Actually, I probably won't. I was going to talk about the history thing as well. I know, Mario, you mentioned that, but that's a completely different thing. But yeah, I guess, what do you think? You mentioned, oh yeah, Mario mentioned like megagas L1 or gigagas L1, teragas L2. I disagree with that notion just simply out of like the fact that conceptually scaling L2s is actually execution sharding, like to a certain extent when you do it in this way. So my argument has always been, okay, if we can get L2s to scale in this way with like ZK rollups and then we use synchronous composability, actually implementing that on mainnet so that we don't rely on, say, like centralized sequencers, centralized builders for L2s is a far better thing than trying to like paradigmatically split it into like L1, L2. So I guess, what do you think about that? Like an L1 centric scaling roadmap, I guess.
I mean, I'm not designing the roadmap, so I can only perspective as a user. I mean, as a user dealing with the L2 is always big, like of delays. Like if you want to bridge something in, that's usually like the 30-minute thing. But if you want to take it out, which is, I mean, it's too. And there are like services like CowSwap that work cross-chain one, but in the end, someone has to wait that week, right? What I find a bit sketchy though is that Ethereum as a platform for developers, like we had a lot of effort towards L2 centric architecture. That was like, hey, we want to, now we have L2s. And now if we just tell them, hey, we promised you this platform and now we completely revamp it and that was it, that's a risk on the application side. Like, why would someone build on top of Ethereum if the core rules keep changing? So that's the risk. Personally, I definitely see the advantages of native rollups, but also, yeah, I mean, if we can make it work with like L2s, that's also fine, I guess. I mean, like if someone wants to use like a gas-free chain like Linea that works differently, or if someone wants to use a specific chain like or whatever, that's fine. And I'm not sure how well that would come out. Like, right now, it's big problem. Like gas fees are super low, and lobs are free. Like any or free on Ethereum. That's like a tools that extract all the money for themselves. They don't pay a lot. Yeah. It's still worthwhile to run node at home. Like a little more than just a code. Like originally with the proof of work days, that was like when people really liked Ethereum at home because they could like get like a fancy GPU and feel like they are part of it. And with every step that we go, servers, like the decentralized.
Sorry, I think you cut out a little bit there. I'm not sure if that was the same for everyone, but yeah, no, I mean, I agree. I mean, rollup. No, I heard it also. Yeah.
Okay. Maybe. Is it still the case, or
Yeah, a little bit.
is it all? Is it? Is it better on this audio? Maybe it's the headphones. Okay. So yeah, like my point was just like I'm not sure what part did you understand and where did I cut off? Can you maybe explain me that?
Well, I heard like a little bit about like the like you mentioned native rollups, and you were talking about like the user experience. I think the nice thing about execution sharding natively is that you can manage basically the load balancing on shards or like quote unquote shards or rollups automatically or dynamically, which is an advantage because you can just basically make it as easy as possible to coordinate with users. So they're not like stuck in these very rigid like spaces, like, oh, I'm on Arbitrum, so I have to only interact with people on Arbitrum or something, you know? But also, I think if you like, ropes will always be good for like custom logic. But if you take something like native rollups are kind of a weird limbo to me. Like if you take native rollups and you say, then native rollups based sequencing, but let's delegate the proving and the computation natively as well, like to the validator set. And then you have some mechanism that lets these native rollups be established and coordinated, like the creation of them be coordinated natively. Then you basically have like dynamic execution sharding, which I think is a more advantageous way of both improving the user experience and scaling than any other rollup mechanism.
Yeah, but like the concern there is that it's just not what application developers were promised, right?
Yeah.
Like we cannot just keep changing like the promise. Like either we have to be upfront and say, hey, this is a temporary thing, or we have to tell them, hey, this is how it will be for at least this period. And then they can work on top of that. Like Ethereum has to mature to a level where it's a reliable platform. But yeah, I mean, there's always better ways, right?
I do agree in principle. I think it's just like the very nature of things is like very like there's a lot of like this idea that like the current roadmap is like set in stone is like not. I just don't believe that. Like everything is constantly changing. I think we have to be willing to accept that things can change and learn to live with that, even as application developers. Like I don't like the idea that we're just going to say, okay, no, this is what we're going to promise, in terms of like L1, and then we're just going to keep it that way. I feel like we have to
Yeah.
be ready to adapt.
I agree. I just want to minimize changes that are like avoidable. Like if we already know that it's a temporary architecture, we should say that up front. Also, like one of the EIPs that I just landed in Amsterdam, that one is actually interesting for staking pools like Lido Rocket Pool. We had this thing in the Beacon chain where the data structures, like if we add more features, then randomly the memory layout would change sometimes when there is a new fork. And then even when nothing changed for these staking pools, they still need to update their smart contracts for these new memory locations, right? So they have to go like through security audit. The security council has to approve the smart contract updates and so on. So now with Glomstrom, we give them forward compatibility so that as long as we are still in SHA-256 and as long as the features that they care about don't change, that they don't have to change smart contracts anymore, right? So if we can give guarantees on some level that like you can like rely on this working like this for a while, I think that's fine. But if we tell them, hey, we are L2 centric, and then like, it's like, oh, now we don't want L2s anymore. Maybe like you can distinguish yourself with different kind of funding or whatever. Yeah, I don't know. But I mean, it's also like a topic that's completely above my level, right? Like I cannot change roadmaps or anything.
I do think there are ways to kind of modularize in a way where it's forward compatible. Like for example, EIP like 4844 or even like what is it 8025 like native rollups. Both of them deploy this paradigm of like we're going to do something really simple now, and then it's going to be forward compatible with like whatever we do. So like 4844 was compatible with PeerDAS, in a way that like it was one UX change just to implement data sharding for like the entire future. Native rollups like 8025 is supposed to do the same thing, or what is it? The optional proofs again. Like I do think there is a way to kind of do things in a way where it's like, okay, we're gonna make one big change now. We're not really gonna implement most of what we want to, but when we implement it in the future, nobody will need to change anything, which is one way
Like
of doing it.
it's not 100% correct. Like 4844 already was immediately deprecated, and now we have like colons. So the way how you access the blobs has changed, and maybe there will be cells, so that changes as well. And like the lip2p stuff keeps changing. Maybe where like the aspect where you're right is like the transaction itself, that one didn't change. But like the way how the data is stored, how you have to access it, that definitely changed.
Yeah, that's fair. That's fair. Thank you.
Like it was also a bit of a like for example, Aztec, they wanted to use these blobs, and then like Fulu came out with data columns, and then it was like, oh, now you have to be a super node, even if you just care about a single blob, right? Because like you have to get more than half of the columns to reconstruct a single row, right? So they
Yeah.
originally they wanted home stakers, and then they had like to choose a different DA. It's like, yeah, it has to become better. Like with like communication at least, like to tell them the plan. Hey, we know that you are here right now. This is your understanding. This is where you want to be, and like guide them through the process. Give them enough heads up.
Yeah, that makes sense. Thank you. I think there's another question there.
$7792 was a very early draft that I made with Gajinder based on just the idea of storing logs. We initially just because like we had this question before, who is storing the logs, right? The historical logs. And in the initial prototype with Gajinder, we just put it into the state as well. Like we had like a special contract and we just shoved everything in there. And it's just way too expensive, like to put it into a big try like that. Because like even if you change a tiny thing, you have to rehash everything that's above it, and it's just too expensive that way. Especially if it's a free thing, right? That just happens by the system in the background as a service. So I think the newer designs, like the log filters and like the 7745 or the 8, I forgot the number, but 8304, like those are better designs than the 7792. Like the Lightline Bootstrap, like initially you only have a block root. That's all you start from. Only a single block root. You don't have a sync committee, you don't have a state, you don't have a block even. You just have a single root. And the Light Client Bootstrap gives you the initial sync committee for that root. And once you have that sync committee, that allows you to process Light Client update messages, and those allow you to sync to the present. So the bootstrap is just the initial message to turn the block root into a block header and the sync committee. I hope that's clear. Otherwise, just ping me on Discord. Like it's a component I know very well. Huh. I think an important aspect is like embracing like failure in a way. Like sometimes you have to try different approaches and then you get stuck and then you have to work through why did I get stuck? But like it doesn't mean that you made a mistake. It could also be like that you just need to contribute back to the specs. Maybe like the other people who gave you a task didn't think everything through. So I think the most successful people there were really like people who did not, like who had like flexible minds in a way. Like instead of just having a linear, this is their plan and I just follow it and like, oh, now I'm stuck and then I bang my hand against the wall for like 3 months. Just contribute back, ask questions, ask each other, right? Especially with the research heavy topics that are not yet ready to be integrated into a spec. Yeah, thanks for